Good day, everybody, and welcome to this presentation from Cansel Survey Equipment and CSDS. Today, we're going to be looking at innovations in Lidar, the latest technologies across various industries. Our speakers will include Amar Kalsi, our Segment Manager for Terrestrial Scanning, Jean-Michel Dupé, Segment Manager for Rail and Monitoring, David Laflamme, our Segment Manager for Aerial and Terrestrial Imaging, and Stephen Vickers, MGIS and Software Solutions Manager. In the presentation today, we will cover terrestrial scanning, some scan to BIM and CAD projects, tunnel and rail projects, including profiling and cavity surveys, mobile mapping, i.e. large-scale transportation and infrastructure projects, drone and UAV surveys covering corridors, stockpiles and mining projects, and bathymetric surveys, surveys of water bodies, and that will be followed by a live Q&A from our presenters. And at this point, I will hand over to Amar Kalsi.
Thank you, Steve, and thank you everyone for your time today. Terrestrial scanning solutions are one of our key product offerings here at Cansel/CSDS, and I'd like to take a few minutes to highlight our capabilities here. We have had many years of experience working in this space, and I would like to share some information associated to a project we recently completed reflecting exactly this. Dialogue Architects, an existing Cansel client, approached us to discuss a new project that had just been awarded to them. A portion of Commerce Court, a large and well-known building located in the heart of Toronto's financial district, was due for a massive and major renovation. This would encompass multiple stories of the building, including parking levels, food courts, open areas, retail stores, pathways, meeting rooms, and restricted areas. As with many older buildings and facilities, existing 2D and 3D documentation was either very outdated or missing completely. And of course, without accurate spatial data, it simply wouldn't be possible to plan for any of the changes and renovations that needed to take place. Dialogue quickly concluded that a scan to BIM approach would be best suited to this particular project. But due to the lack of resources in-house, the high level of complexity, and the short time frame for the completion of the work, Dialogue chose to partner with Cansel to complete this task. Numerous challenges presented themselves at the commencement of and throughout the duration of this particular project. Much of the scanning work had to be completed after hours, i.e. during the evenings and on weekends. In addition to this, escorts were required and mandatory for certain areas of the facility to ensure privacy, and needed to be met to for other security reasons as well. Despite all of these challenges that were in place, ultimately over 1,100 scans and 600,000 square feet of space were successfully captured. The complexity of the registration required very much a fine-tooth comb approach. This was needed to ensure that all intricate details, traverse closures, and final residuals were well within architectural and engineering grade tolerances. This was a specific requirement of the project itself. The registered point cloud model then needed to be converted to BIM. Element extraction software packages were primarily used here to create most of the required architectural, structural, mechanical, and fire protection deliverables. Manual techniques were also used to create the outstanding elements. A very stringent final QA and QC process was also employed. This included physical spot checks in questionable areas, and essentially was the last piece to finishing up the as-built portion of the drawings. The final product was an incredibly precise Revit LOD 200 model, completed on time and within budget. Despite being one of the larger scan to BIM projects that Cansel has performed over the past many years, this proved to be one of the most rewarding projects for all involved parties. This project was documented in a case study and can be made available to all interested parties upon request. I've also included a link here within this document. I've also shared a copy of one of the sections of the Revit model. A client was kind enough to give us the ability to kind of show you that. This clearly illustrates the final project, the complexity, and everything else that was just mentioned a few minutes ago. Thank you again for your time, everyone, and we certainly look forward to any questions that you might have related to this presentation at the end of this meeting. With that, I pass it over to you, Jean-Michel.
Thanks, Amar. Hello and welcome to this short presentation on the scanning challenges in a tunnel environment. My name is Jean-Michel Dupé, and I'm the segment manager for rail and monitoring portfolio at the Cansel CSDS group. If you are new or never considered scanning in tunnels. We hope you can learn a thing or two for your next project. And if you're already familiar with these concepts, stay tuned. We might have a product or a workflow to make you save time. Reasons to use LiDAR in a tunnel are numerous. It might be during the construction process to validate the design. It might be part of a preventive maintenance program or an emergency monitoring program when a problem is detected. And it could simply be to document the existing state when it has never been done before. Tunnels that they are made for pedestrians, vehicles, or rolling stock, and we could add the smelly stuff in there too, share the same long linear feature with usually limited space to operate. As you know, scanning relies heavily on data overlap for the registration of the scans together, but also for quality estimation. Even if you use targets and sphere in a tunnel environment to help with registration, it is difficult to keep true to the tunnel alignment. And obviously, the longer it is, the bigger the challenge. That is why tunnel projects where high absolute accuracy is needed will often need to be complemented by survey measurements, similar to adding ground control points in a UAV project. Using these survey controls along the tunnel will allow the point cloud registration to be more accurate and not drift along the alignment. This brings us to another challenge. Tunnels are usually critical infrastructure that are difficult to close for any type of work, specifically with rail, where track access might be limited to a few hours in the middle of the night. Having to arrange the logistic for the scanning run and the survey control run add to the complexity of any project. As you see, scanning into tunnels has a certain level of complexity to it. When working on a rail tunnel project, there will often be the added challenge of tying the point cloud data to the actual tracks, which might sound simple at first, but it is actually more complicated than to reference to a large regular surface like a roadway, for example. The rail world comes with a specific sets of measurements reference point, and it's not easy to extract out of a point cloud. Accuracy in these measurements are important, especially when the goal of the project is to gather data for clearance analysis of the rolling stock. Another challenge that has less to do with data acquisition, but rather data processing, is to have a software that can handle tunnel design. Lots of software can handle surfaces created from UAV point clouds where the ground is the reference, but a lot of them are showing their limitation when dealing with vertical walls, overhang, and other complex features. To be able to generate interesting deliverables in a tunnel, you will need a software that can produce complex surfaces that will allow you to compare their evolution in time, or a software that can handle tunnel design to validate conformity in a new construction project, for example. So let's quickly summarize the challenges we just discussed. So as we discussed, long linear features make it challenging for registration accuracy, often requires the use of survey crew and additional equipment to establish controls. Tunnel rail with live traffic have limited time for maintenance. And to compare point clouds to design in closed space, you need a software that can handle tunnel design. And as we said, it's not easy to tie the point cloud to rail elements for clearance analysis of rolling stock and rail specific measurements. So some of the solutions to be considered to mitigate these challenges are quite easy. And Amy, if you can switch the slide for me, please. To help speed up the data collection process, some manufacturers offer a total station and a scanner hybrid, combining an high accuracy total station to a LiDAR. The trade-off is usually point density, but tunnels are closed up areas, and on short distances, you still get enough density for detail analysis. You can save time by doing the control network and the scanning in the same pass. It allows more control on specific areas of interest. For example, you can redo a scan with a higher density in a specific area that's of importance. And the point clouds are already tied to the survey network at the end of the survey, potentially eliminating the need to do registration at the office, which is a big plus. You can see the current slide, an example of this hybrid instrument at work, combined with the software that can handle tunnel design and models for production of deliverable. Specifically for rail application, and again, I will invite you to change the slide, please. Specifically for rail applications, another solution is to change the approach. Instead of trying to fit a scanning workflow to the rail world, we suggest using a rail workflow and add point cloud to it. This is done by using end-push track trolley systems that offer a wide range of field and office software solutions to maximize the use of LiDAR technology in the rail industry. These trolleys have some internal sensors that will measure track geometry and can be combined with other sensors like an inertial measurement unit and a scanner to capture data with different levels of productivity. The data, as we discuss, will ultimately be referenced to the tracks and ready to use for further analysis and modeling. Maybe you can switch to the last slide. As you can see, those images represent the office software where you can kind of do clearance analysis and so on, or some scan to BIM workflow. So that is a lot of information in a small time frame. If you're interested in learning more about these solutions, don't hesitate to reach out to our team. Thanks for your attention. And on this, I'll pass to David.
Thank you very much, Jean-Michel. Good day, everyone. Today I'm going to discuss some LiDAR data collection using drone and vehicle-based system. My name is David Laflamme, and I'm the terrestrial and aerial imaging segment manager. We'll start our presentation today with the drone portion of it. So we started seeing some drones actually for professional use about 10 years ago. The technology that was used in that time was more related to photogrammetry. And about 3 to 4 years ago, we started seeing LiDAR payload being more and more popular, and they are getting to really cheaper in terms of pricing. LiDAR drones is now what will be discussed in the next few minutes. I based my presentation today on the different industry challenges that we saw, and with the audience that we're having, I'm sure that you already face at least one of those challenges. Human resources. So if we look at this, more than ever, the human resources challenges is getting a real problem for industry, in the industry. It is a challenge in terms of number of resources available, but also in terms of qualified resources. New and emerging technology can help you with this challenge in two different ways. The first one, you'll be more effective on the field. So you'll be able to collect more information way faster. So you won't need as much people compared to different surveys. The second way is the new technology. The second way is the new technology will help you to organize to be even more, to help your organization to be even more attractive and for qualified resources. The other challenges that we're facing is the security. Employees need to stay safe and healthy while working. There's nothing more important than this. Sometimes on different projects, you have to work in the middle of the forest, close to really sharp creek, on unstable terrain, etc. While using a drone to collect data, you won't have to place a foot on the field on those unstable terrain, and you won't have to climb on top of a stockpile, for example, to get a GNSS shot. I'll try to work in a very dense forest and get some points collected. The drone and its payload will get all of this for you. Finally, we all know that the more conventional survey equipment, such as GNSS, total station, can be limited when comes the time to survey that acquisition on a large-scale project. They are still the bread and butter for surveyors, but with the complexity of the project that are now available, those conventional equipment can be paired with the LiDAR data acquisition that we're talking about. Again, a drone solution using a LiDAR payload will cover more area in less time with a really good accuracy. And that brings me to this solution, actually. So what is a drone-based LiDAR system? The drone-based LiDAR system consists into a LiDAR laser scanner installed and calibrated with IMU, GNSS, and cameras mounted on a drone to collect accurate position, images, and distances while flying. Usually, due to the weight restriction with the UAV, the IMU and camera are slightly smaller, and what we can see on vehicle-based system, but can still give you a really good accuracy. The LiDAR drone is a solution in the industry challenges that we discussed earlier. It will allow you to collect 100 meters wide data at a speed of 8 meters per second from the air. This means you can collect easily, safely, and quickly data on the ground without having to place a foot there. The LiDAR mounted on the drone will allow you to acquire point clouds of an area to start your design or volumetric calculation after a few minutes on the site. You can also see in the example here that we are collecting, colorizing, and classifying the data to get a straight topo. From this topo, we can easily do some analysis, start a project, do volumetric calculation, and many more. You also probably mentioned that the image of the drone flying over a power line. This means you can fly power lines with only one pass at a speed of 8 meters per second, which is approximately 30 kilometers an hour, and you will be collecting 10 kilometers of power lines within a 25 minutes flight. Once in the office, you'll be good to do any type of design calculation and many more analysis on the data that you just collected. Finally, compared to photogrammetry, the LiDAR will have a lot of benefits while flown over forested area, over a corridor map to do corridor mapping, or you will gain in productivity when you're looking at processing time. We're now moving to the vehicle-mounted mapping system, so the mobile mapping. So the mobile mapping technology is newer than the drone's technology. The first mobile mapping system has been released about 15 years ago, but it started gaining in popularity and are more efficient since the last 6 or 7 years. This part of the presentation has the same structure than the previous one around the drones. We'll base this on the industry challenges, and you probably mentioned that the first two challenges that are listed over here are the same than with the drones. I am sure that those are really common challenges and that can be solved or helped by the different technology. But again, human resources. Won't spend much time on this one, as mobile mapping has the same benefits on human resources than drones, namely the speed and attractivity. The security. So we still have something around security here. So it's similar to the drone. You can survey area without putting a foot on the ground. So sometimes, for example, on different projects, you have to collect data on the highway with traffic driving crazy 24 hours a day. Then you have to you can be part of the traffic actually with the mobile mapping system and collecting data while following everyone on the road. Without mobile mapping system, surveyors had to be on the side of the highway to collect data, and this can get dangerous really quickly. And finally, the tight deadlines. This is another challenge for small or big projects. Today's technology can help you to increase your field and office productivity. I'm not spending any much time on the software today, but this is a really important steps that for the productivity as well. If we're looking at the hardware, we are looking at we can collect data up to 100 kilometers an hour at a scan rate of 2 million points per second on 3 lanes at the same time. This is a game changer. Over the point cloud, we're also collecting images to colorize the point cloud as well as viewing purposes. And now what is a base mobile mapping system? So the technology that is there. So it's similar to the drone. So we have a laser scanners that are installed. So it can be one or more than one laser scanners installed and calibrated with the IMU that we've been talking about, as well as GNSS and different cameras to collect accurate position, images, and distances while driving at a speed up to 100 kilometers an hour. By driving at this speed, this vehicle-based system, you can collect easily, safely, and quickly tons of information to bring the field into the office. So what does the data looks like? So when we look at the few images here, so everything that can be scanned while driving can be collected and digitalized or extracted. The density of the point cloud is impressively amazing, and it is directly related to the driving speed. You are also collecting all of the information on the pavement. So for example, pavement marking, cracks in the asphalt, manholes, edge of pavements, and many more information, as well as the asset outside of the road that might be needed for different inventory. And finally, you get images of everything. By looking at the images below, you can see 2 images of our Trimble MX9 and some screenshot of the point clouds it collects. There is some road information on those images, but also a lot of information on different poles and signs if you look carefully on the image at the top right of the screen. If you're driving at a speed of 50 kilometers per hour, for example, on the road, and the distance between the pole is 30 meters, this means you can collect 25 poles per minute. This is a really good productivity information. So again, thank you very much for your attention today, and I'm now passing it over to Mr. Vickers.
Thank you, David. In this presentation, we're going to take a quick look at bathymetric surveys and the use of unmanned survey vessels. The challenges we face in this industry are safety and accessibility. We want to minimize the amount of time we put people on the water, the cost of running manned vessels, and the efficiency of integrated workflows, combining below water with above water data. So the technology we'll be looking at are multi-beam echo sounders and the unmanned survey vessels themselves. So the solution is to use an autonomous survey boat. These can sail at up to 5 knots, They can be used quickly and easily, and they can safely collect large amounts of seafloor or seabed data, which can be integrated with data from above the waterline to create a single homogeneous point cloud or model. A multi-beam echo sounder is a type of sonar used to map the seabed. Like other sonar systems, multi-beam systems emit acoustic waves in a fan shape beneath the transceiver of the multi-beam echo sounder. The length of time it takes for the sound waves to reflect off the seabed and return to the receiver is used to calculate water depth, and by default, we're able to create a 3D representation of the seabed. Data can be captured, as I said earlier, by both manned and autonomous vessels, which can be then processed and georeferenced, and typically the end result is presented as a point cloud, so very similar to the data we've been looking at with the other solutions. The applications for this type of survey include floor mapping, environmental, dredging, and construction surveys. So below the waterline, in addition to using a multi-beam sensor, we can also add side-scan sonar, subsurface profilers, a single beam echo sounder, or acoustic Doppler current profilers. Above the waterline data capture could also include conventional Lidar, forward-looking infrared, or photogrammetry, potentially all recorded by sensors on the boat. And in the example here, this is a seafloor EchoBoat 160. It's an autonomous system, or as well as traditional land-based survey observations. The point clouds generated from multi-beam bathymetric systems can be combined with terrestrial LiDAR, either from a kinematic scanner, such as a Velodyne on the survey vessel, and operate in much the same way as the mobile mapping systems David spoke about, or by blending data sets in a post-processing workflow. This could include data from both bathymetric and land-based scanners, depending on the accuracy requirement or the scale and scope of the project. Blending data from below and above the waterline allows a complete picture of a project environment to be formed. In addition to the sea or lake bed, we can now add adjacent marine structures such as piers, wharfs, and bridges into the data and manipulate it within a single software. And at this point, all four presenters are now open to a quick question and answer session.
Hi, everybody.
Hello there.
Hi, everyone.
Thanks so much for that presentation. I did my LiDAR training at COGS, so I'm talking to the Cansel folks, so I'm going to assume you guys know COGS pretty well. Timothy Webster taught me about 20 years ago. I didn't stick with the LiDAR. I've kind of branched out since then, as you can see, but it's really exciting to see all the new technologies and things, especially the bathymetry. Why don't we jump right into the Q&A? We've got some questions here to dive into. There's a general question here. Any advice for those flying LiDAR-enabled drones over salt marshes?
Or Jonathan, can you just repeat the question again, please?
So, yeah, sorry, I don't know who to address the question to, so I'm putting it out to the whole panel. So any advice for those flying LiDAR-enabled drones over salt marshes?
No, no special advice. As long as you're respecting all the Transport Canada regulations, stuff like that, you'll be all good to be able to fly those LiDAR drones over where almost everywhere that you would like to, as long as, again, as you are you're looking at something that is according to Transport Canada regulation, all good.
Great, thank you for that. So there's a general question here about, does Cansel offer software products and support?
Yes, we do, for all of the above applications that we spoke about today.
And if they want to learn more about that, where can they visit the Cansel website? They'll see a full list of that.
Absolutely, or they can ping any one of us that are on the meeting here today via LinkedIn after the show. We are certainly more than happy to answer any questions that anyone might have.
David, you were mentioning Transport Canada regulations. Can you give the audience, because I think there's a lot of folks from the States wondering, how do the regulations in Canada compare to, if you have this information, to the US? For instance, beyond visual line of sight type applications and some of these kinds of things. Can you give us a quick update to what things are like and how they're maybe progressing in Canada?
Sure thing. That's a really good question, actually, around that. If we're looking at Transport Canada regulation, not really involved into the FAA regulation, to be honest. But looking at the Transport Canada regulation, you can fly the drones up to 400 feet above the ground. There's different some sort of licenses that you can obtain from Transport Canada. So you get the basic licenses, you get the advanced one. The advanced will allow you to fly closer to people, maybe over people, depending on the drone that you'll be using, and will also allow you to be able to fly close to, well, inside of controlled airspace, which means close to different airports. Again, with all of the approval from NAV Canada around that. If we're talking about the BVLOS, so the Beyond Visual Line of Sight, and in Canada, what you have to do to be able to do that, you really need to get an SFOC, so a Special Flight Operation Certificate, to be able to operate beyond visual line of sight. I know that there have been some discussion around that, but at this time, this is what's required to be able to fly a BVLOS.
Does Cansel sell complete drone systems, drone sensors and software?
Exactly. The system that we have available at Cansel are all related to all complete solutions. So we do have a solution, for example, from Micro Drones, is the drone, you get the software, you get the flight path process creation software, and you also get the Lidar post-processing software that will be available inside of this complete solution.
Fantastic.
Yeah.
There's a question here about, can you describe your technical support services?
At a very high level, we have a dedicated team of individuals specifically looking after that particular market. It's our professional services team. So they cover technical support, pre-sales, post-sales support, customizations, workflows, everything under the sun related to all of our product offerings. So not just all of the Lidar stuff that we spoke about today, but even our traditional solutions, total stations, GNSS, everything that Cansel sells and supports is fully sort of encompassed with our professional services team.
Are there any Lidar mounted drone products you would recommend for agricultural purposes, terrain leveling, drainage, where extremely high accuracy is not necessary, but resiliency in weather conditions is very important?
All of the drone that we're supporting. So again, it's going to be a good question for Lidar. It's to be able to get a better accuracy, but also a stable accuracy on the whole complete flight. Lidar will help you a lot. Regarding the different information around the weather that you'll be able to use the system, most of the system that we are supporting, that we're selling, will be able to fly in really harsh conditions. So even if it's windy out there, if it's cold outside, if it's raining, you'll be able to collect the data and you'll be able to get everything proceed and get you the information around drainage without any problem.
Great, thank you very much. There's a question here from Neil. Is it possible to do bathymetry from airborne Lidar?
It's a good question. I heard about one system actually that was available in the past with a green Lidar to be able to do the bathymetry while flying the drones. I'm not sure where we stand right now. I'm not sure if Mr. Vickers may have some more information around that.
It's not something that's currently on our radar. As David said, it's a technology we are aware of, but currently it's not something we as Cansel are promoting. Actually,
Optech down in Toronto does have a bathymetric Lidar sensor, extremely expensive. Yep. Also somewhat still in the research mode. But yeah, there's a few people out there doing it, and I've seen recently some really great results reported from some of them. Obviously, the clearer the water, the better. So if you can fly it down in the Caribbean, you're in really great shape. But don't know about up north here. But
yeah, I mean, it'd certainly be an interesting piece of the puzzle in terms of blending below surface and above surface data sets, that's for sure.
Yeah, it's powerful technology if they can get it to really work. Yes.
Great. We're going into our break, but I think we got time for at least another question. There's another one here. What should I do if I'm having trouble getting returns through dense vegetation, tall grasses? Thanks.
Always depending on the technology that we're talking about, but if we're talking about the Lidar drones, usually flying lower, flying slower will give you better returns actually from the lasers. It's always depending also on the number of returns that you will get with your sensors. But again, flying lower, flying slower is probably the best route to go for the different tall grass that you may have.
Great, thank you very much. So we're into our break. There's some more questions. I would suggest the audience connect with the Cansel folks through their LinkedIn contacts. You guys can also post your emails in the chat window and some general info pages. That would be great for everybody in the audience. Thank you for being our silver sponsor. Gina, anything you wanted to close up with?
No, same for me. Just really appreciate you guys all taking the time out of your busy schedules, and look forward to working with you in the future.
Thank you.
Thank you for having us.